So, good day sir. I am Ludimar Buisan Baing, a BS Ed Math 2 student at GHCSE Main. So, today I am discussing the Zermelo Fraenkel's axioms. So, the content of this study is 3. The Zermelo Fraenkel's axioms, the intisets, and the power set of a set. So, Zermelo Fraenkel axioms, in 1905, Zermelo began to axiomatize set theory, and in 1908, he published his first axiomatic system consisting of the following 7 axioms. So, before that, let us discuss the Zermelo-Fraenkel axioms. What is the meaning of this? So, it is a set or a set of axioms that compiled by Ernst Zermelo and Abraham Fraenkel that make it very convenient for set theorists to determine whether a given collection of objects with a given property describable by the language of set theory could be called a set. As shown by these paradoxes, such as Russell's paradox, some restrictions must be put on which collections call sets. So, as what I've said, there are 7 axioms that his first axiomatic system. So, first is the axiom der axiom der Bestimmtheit, which corresponds to the axiom of extensionality. The second is the axiom der Elementarmingen, which means that it includes the axiom of empty set as well as the axiom of pairing. So the third is the axiom der Aussonderung, which corresponds to the axiom schema of separation. 4 is the axiom der Potenzming, which corresponds to the axiom of power set. 5 is the axiom der Vereinigung, which corresponds to the axiom of union. 6 is the axiom der Auswahl, which corresponds to the axiom of choice. Axiom des Unendlichen, which corresponds to the axiom of infinity. So, what happened? So next is the axiom 1 to 5 and axiom 7. All axiom except axiom of choice form is so-called the Zermelo's axiom system. So the axiom of empty set. So the axiom of empty set means extensionality pa di. So first is the axiom of extensionality. So the axiom says that any sets x and y having the same elements are equal. So dapat parehas sa x and y. So this axiom established the most basic property of sets. A set is completely characterized by its element for all x, for all y, and for all z. Z is an element of x if and only if z is an element of y. Therefore, x is equals to y. So dapat parehas sa x og si y ani nga axiom of extensionality. So the axiom says that any sets x and y having the same elements are equal. So sa nagbalik-balik na. So the axiom of extensionality also shows that the empty set postulated by the axiom of empty set is unique. For assume that there are 2 empty sets, x sub 0 and x sub 1. So dapat sa x sub 0 ug sa x sub 1 is equal. So second is the axiom of pairing. So this axiom of pairing is denoted by the for all x, for all y, for all u, and for all z, where z is an element of u if and only if z is equals to x and z is equals to y. So dapat duha ka si x and y kay kuan siya kanang what you call this, parehas sila sa value ni z. So kung value si x ni z, dapat si y value po ni z. So notice that by the axiom of extensionality, the set U is uniquely defined by the sets x and y. So we can define the binary function symbol nga period dayon kama sa tunga tapos period sa kinalasan by stipulating x and y, u sama sa gingon ganiha sa for all x, y, u, and z, where z is equals to x and z is equals to y. If x is a set, then also x if x is a set, then also x is a set. Now starting with an integrated application of the axiom of pairing yields for examples of sets. So third is the axiom of union. This axiom, we can define the unary function symbol u called union. So ito mo siyang na-discuss sa logic sa set theory na to nga topic atong first sem. So union for all sets X, there exists the union of X, which consists of all sets which belong to at least one element of X. So with this axiom, we can define unary function symbol union by stipulating for all X, U, and Z, where Z is an element of U, if and only if there exists in W element of X, where Z is an element of W. So informally, for all sets X, there exists the union of X, which consists of all sets which belong to at least one element of X. So example, union of the element of X. So fourth is the axiom of infinity. So from the word if infinity, so it postulates the existence of non-empty inductive set containing null set. All the sets 0, 1, and 2 constructed above, which we recognize as natural numbers, must belong to inductive set. So if there were a set which contains just the natural numbers, it would be the smallest inductive set containing the empty set in order to construct this set. We need some more axioms. So it is denoted by there exists an I, null set element of I, and you call this IND, inductive. So that is denotes by the axiom of infinity. So no. So number 5 is the axiom schema of separation. If A is a set, there exists A set B such that for all X, X an element of B if and only if X is an element of A and S is X. Her S of X is any condition of X in which B is not free. It must be bounded by a quantity such as all or some. So that for each formula Z, P1, and Pn with free P1 and Pm, the following formula of action is for all X and for all P1, for all Pn, and where there exists Y, and there for all Z, Z is an element if and only if Z is an element of 6 and Z is P1 Pn. So informally, for each set X and every first order formula, Z is an element of X is a set. One can think of these sets P1 to Pn as parameters, which are usually some fixed sets. So 6 is the axiom of the power set. So if A is a set, there exists a set B called its power set, such as X is an element of B if and only if X so you call it subset of A. So subset of A. So informally, the axiom of power set states that for each set X, there is a set P of X called the power set of X, so which consists of all subjects. More informally, we define the unary function symbol P by stipulating P of X is equals to Y if and only if for all Z, Z is an element of Y if and only if Z is a subset of X. So the set. So as an application of the axiom, we have so far we define the smallest non-empty inductive set containing null set. So it is denoted by the W, which will be the smallest set containing the natural numbers. So next is the action schema of replacement. So actually, kini si axiom schema of replacement o kini si axioms of foundation, tapos kini sa axiom of choice kay nadugang ra ni siya sa pito ka buok nga axioms. Kay in 1992, Fraenkel and Skolem independently improved and extended Zermelo's original axiomatic system. So and the final version was presented again by Zermelo in 1930. The two axioms we had to add to Zermelo's system from 1908 are the axiom schema of replacement and the axiom of foundation. So bali kini si axiom schema of replacement o kini si axiom of foundation kay nadugang ra ni siya sa pito kay gipa-improve ni siya ni Fraenkel and Skolem kay katong si Zermelo pay nagunit ani pito pa ni siya kabuok. So In this section, we'll present the remaining axioms, though called the Zermelo-Fraenkel set theory with the axiom of choice, denoted Z of C, which consists of Zermelo's axiom system Z together with the axiom schema of replacement. So, kung magisgot ni Zermelo, so balik kini silang tulo, dili inta ni sila part. Pero since it is an axiom, so i-discuss na lang po nako unsa ni silang tulo. So, action schema of replacement. So the action schema of replacement, if A is a set and f of x and y a formula in which x and y are free such that for x is an element of A, there is exactly one y such that f of x and y, then there exists a set B, the members of which are the y's determined by f of x and y as x ranges. So for every set order formula, so P, X, Y, P, which with free P is equals to X and Y, where P can be the ordered n tuple of parameters. The following formula is an axiom for all A, for all P, for all X is an element of A. Tapos sa P is the parenthesis of X, Y, and B, P, where there exists B for all X is an element of A, and there exists y is an element of B, and x, y, and p. So in order to reformulate the axiom schema of replacement, we introduce the notion of a class function. Let p, x, and y be a formula with free p is equals to the bracket of x and y, such that for all x there exists y p of x, y. So 8 is the axiom of a power set. Axiom of the axiom of foundation. So every non-empty set of contains an element B such that A intersects B is equals to the null set. A and B have no elements in common. So as a consequence of the axiom of foundation, we see that there is no infinite descending sequence. So as a matter of fact, we would like to mention that if one assumes the axiom of choice, then the non-existence of such infinite descending sequences can be proved the equivalent to the axiom of foundation. So si axiom of choice kay dili siya mo exist kung infinite si descending sequences sa axiom of foundations. Sakto ba? Can be descending sequences can be proved to the equivalent to the axiom of foundation. So this axiom of foundation is denoted by for all x there exists z, and z is an element of x. So if and then there exists y as an x is y intersects x is equals to the null set. So that is the notion of the axiom of foundation. So last nga nakuha na siya na damay sa axioms, pero di ni siya parts ni Zermelo's axioms, pero axiom yapon siya, which do you call this? The axiom of choice, which is if A is a set the elements of which are non-empty sets, then there exists a function f with domain A such that for member of B of A, f and B is an element of B. So for all f there exists f is a function from f to union what do you call this? F of x is an element of x. So informally, every family or non-empty sets has a choice function. So where are we? Power set of a set. So as a recall in our set theory, kana na-discuss na ni si power set of a set. So sa atong nabantayan, kung pila kabuk ang elements, mao po na siya ang nabutang sa power, which means 2, butang na tulo ka elements, 2 to the power of 3, which contains 8 elements. Example lang to siya. So it's the set of all subsets of S, including the empty set and S itself. So it is postulated by the axiom of power set. The power set of S variously denoted as, so mao ni siya katong P of S nga magkuan siya og pila ka buok ang elements. So or should I say nga 2 to the power of S na lang para mas dali. So kung pila imong elements mo yung butang sa power. So that is a power set of a set. Ano sa man eh? Wait. Yun. So the notion 2S, meaning the set of all functions from S to a given set of 2 elements, is used because the power set of S can be identified with is equivalent to or bijective set of all function is given to an element set. So dili na kay nato na siya complicated, kay ang pasabot ra gyud ani ni power set kung pila ka buok ang elements. Pareha ni example, naa siya elements of x, z, y and z. So tulo man ka buok elements si x, si y ug si z. So 2 to the power of 3 is 8 elements. So ato siyang i-try kung walo ba gid siya ka buok. So power set is equals to the null set, the x, the y, the z, xy, xz, yz, and xyz. So there are 8 elements. So mao gid siya ang gamiton ani nga topic nga power of set of a set. So kato sa 2 to the power of set. So that's all of my part in this reporting about the Zermelo's Fraenkel axioms. So thank you and have a good day.